Hi and welcome back to My Physics Teacher by Mr. Cannon. By the end of this video, we will have reviewed the definition of vectors and scalars, so what we mean by each of them, and then the difference between them, as well as some examples of vectors and some examples of scalars. Right at the end, so stick around for some example flashcards so that you can focus your revision. So we'll start off looking at the key terms and definitions of scalars and vectors. So a scalar quantity is one with a magnitude only. And a vector quantity is a quantity with both a magnitude as well as a direction. So if we look at how we draw vectors, well, we use an arrow, and the arrow is linked to the length of it. The length represents the magnitude, so the longer the arrow, the bigger the number. And then the direction, or the angle that the arrow is, that tells us the direction of whatever we're looking at. So for example, a force. One example is temperature as a scalar quantity. It's just a magnitude, or it's just a number. So say 10 degrees. There's no direction to the value. Other common scalar examples, so mass, again, just a number, a magnitude. Distance, speed, density, and energy, they're all scalar examples, magnitude only. The first example of a vector would be a force, so it has a magnitude and a direction, just like in the example with the arrows above. Another example of a vector quantity would be weight, so that's in the force due to gravity, pulling us down to the centre of the Earth, so it's very much directional, a magnitude and a direction. Displacement, velocity, acceleration and momentum, direction is really important with those, so magnitude and direction are vectors. If we now look at the question on the right hand side, so we've got a dog in a crate moving at constant speed in a straight line. So the child here is pushing with a force of 100 newtons. So question 1, draw an arrow on the diagram to show the direction of the frictional force acting on the moving crate. So forces act in pairs, the child is pushing forwards, so the friction is going to be pushing in the opposite direction to the right. For number 2, it says state the size of the frictional force acting. So we've got 100 newtons pushing forwards, we've therefore got 100 newtons pushing backwards, equal and opposite forces. When we talk about vector quantities, so a force, the size of the arrow represents the magnitude, 100, and the direction of the force represents the direction of the vector quantity. And in this case, it's to the right. Now it's time to make a couple of flashcards on this topic to review what we've done. These are my examples. So we have a vector on one side and then some information to write on the back. So vector, magnitude and direction. We show it with an arrow. And then the length is important, that represents the magnitude, how big the vector is, and the direction. Some examples, force, velocity, and displacement. On a separate one, we can put scalar, which is just magnitude, just the number, and some examples include energy, speed, and distance. Thank you for watching, and if you enjoyed, don't forget to share, like, and subscribe for future videos. See you next time.